progressions, the n terms of an arithmetic progressions can be written as Tn equal a plus n minus 1d, such that a the first term, d is the common difference, n is the number of terms. You can check out example 3, example 4 and 5 in your textbook, page 131. Now I will show you additional examples on how to use the formula Tn we have learned just now in various situations. Question 1, given an arithmetic progression 42, 39, 36, 33, A determine the n term. So first thing first, find the value of the first term. A is equal to 42. D is T2 minus T1, which is 39 minus 42 is equal to negative 3. So now we can answer the questions. So from the formula, Tn is equal to A plus n minus 1 d. So substitute A is equal to 42 plus n minus 1 negative 3. Then we simplify. Then we will get Tn is equal to 45 minus 3n. B determine the ninth term. T9 is equal to 45 minus 3 bracket 9. You will get the answer is 18. Question 2, given an arithmetic progression 5 plus x, 8 plus 3x, 11 plus 5x, determine the n term in terms of n and x. B, determine the 13th term in terms of x. So for the solution, first thing first, A is equal to 5 plus x, D is 8 plus 3x minus 5 plus x equal to 3 plus 2x. So Tn is equal to A plus n minus 1d. So substitute 5 plus x plus n minus 1. D is 3 plus 2x. Let it in this form and do not expand. So for B, to find T13, we just substitute n is equal to 13 into the formula we get in question A. Then we expand and simplify. Finally, we get the answer is 41 plus 25x. Question 3, determine the number of terms for the following arithmetic progression: 9, 16, 23, 114. So number of terms here is Tn, T1, T2, T3, Tn. What is the value of n? So Tn is equal to 114. We know that the formula is A plus n minus 1d equal to 114. Your A is equal to 9, D is equal to 7. Substitute into the formula. So n minus 1 bracket 7. 114 minus 9 is 105. N minus 1 is equal to 105 over 7 is 15. N is equal to 15 plus 1 equal to 16. Hence 114 is the 16th term for the arithmetic progression. Question 4, the nth term of an arithmetic progression is given by Tn equal 5n minus 14. Find the first term. So we have to find T1 by using the formula given in the question. So T1, just substitute n with number 1. So T1 is equal to 5, 1 minus 14. So T1 is negative 9. B, find the common difference. So you know that D is equal to T2 minus T1. So T2 equal 5, 2 minus 14. You will get T2 is equal to negative 4. So D is Negative 4 minus negative 9, you will get the answer is 5. Question 5. Given an arithmetic progression 2, 3.5, 5, 6.5, determine the minimum value of n such that the n term is greater than 130. Actually, the question asks at what term the number become greater than 130. Tn more than 130, a plus n minus 1d more than 130, so a is equal to 2, d is equal to 1.5. Substitute into the formula, so 2 plus n minus 1, d is equal to 1.5 more than 130, n minus 1, 1.5 more than 130 minus 2 is 128, n minus 1 greater than 128 over 1.5, you will get 85.33. So n is greater than 86.33. Hence n is equal to 87. So it means that at terms 87, the number become greater than 130. Let's check the answer. Do you still remember the formula? Tn is equal to a plus n minus 1d. So T87 equal to 2 plus 86 times 1.5 is equal to 131. Greater than 130. Question number 6. 4, 1, negative 2 are arithmetic progression. Find the smallest value of n such that the n term is less than negative 60 for the first time. 4, 1, negative 2 until the number here is less than negative 60. T1, T2, T3, and this one is Tn, which is less than negative 60. So Tn less than negative 60, use the formula a plus n minus 1d less than negative 60. So a is equal to 4, d is equal to negative 3. We substitute into the formula. 4 plus n minus 1, d is negative 3 less than negative 60, n minus 1 negative 3 less than negative 64. Then you see here negative 3. So when we move it to the right hand side, the symbol is changed. You see? So n minus 1 is greater than 21.33 plus 1, n is greater than 22.33, hence n is equal to 23. Let's check. T23 is equal to 4 plus 22 times negative 3, which is negative 62, less than 60. Last question, the third term and the ninth term of an arithmetic progression are 10 and 28 respectively. Determine the first term and the common difference. From the information given, we know that the third term and the ninth term is 10 and 28 respectively. So we can write it as T3 is equal to 10, T9 is equal to 28. For this one, you have to make sure you are able to write it in this form. A plus 2D is equal to 10. For T9, A plus 8D equal to 28. And this one is equation 1 and equation 2. We do the simultaneous linear equation. So equation 2 minus equation 1. By elimination, so you will get 60 equal to 18, d is equal to 3. So substitute d is equal to 3 into equation 1 and you will get a plus 2 times 3 is equal to 10, a is equal to 4. Therefore, a is equal to 4 and d is equal to 3.